I've found time very tricky indeed to deal with when you're data modelling. One of the things we said would be a requirement for a notation for data modelling was reducing clutter, to have very little clutter, have the diagram be very simple. And time, I have found, leads to the problem of a cluttered diagram. So what I'm going to do in this module is to show you a way of removing time from the diagram using something that's inherent in the notation itself. In practice, what I found is that the vast majority of attributes and relationships would fail what data modelers call the many test. That is to say that over a period of time, pretty well every attribute and relationship can change its value. Now, in most modelling techniques, and data modelling techniques in particular, this whole feature of changing values over time, which needs to be tracked usually in systems that have to keep track of historical changes for one reason or another, means that you end up with entities in your data model that represent the changes over time. The difference between most modelling techniques and the one that I'm using here is that in this technique the assumption is that all attributes and relationships can vary over time. It's an important distinction because it removes the complexity of time from the diagram. I'm going to do a session on this in a little bit more detail later, but from this point of time, every time you have an attribute and a relationship on a model using the notation that I'm using here, you have to assume that those attributes and relationships can change over time. Let's have a look at an example of that to make sure that we're clear on what we're talking about. So what we're showing on this model here is four entities: college, person, course and enrolment. So as you can see from here, there is the notion that a course is offered by a college. That's the relationship between course and college, and that courses have a code and a name. There's also a notion that the course is run by a person. That would typically be the lead lecturer for that particular course. And at the bottom of the diagram we have the notion of an enrolment. And an enrolment is of a particular person on a particular course, that person being the student on the course. So when we talk about time in a model like this, here's the semantics that are implied by the modelling notation I've adopted. The course has a code and a name, and over a period of time it's possible for a particular course to change, for example, its name. That means the course may have been called architectural design when it was first offered by the college, but now it may be called basic architectural design because the course has a companion which is an advanced architectural design course. And the people who run the course have decided to change the name of the course to fit in with some change in the syllabus that they've extended. In the same sort of fashion, the person has an attribute of name, and over a period of time that person may change their name. The relationships also have the same semantics associated with them. So for example, I've got a course here which must be run by one and only one person. That's true at a point in time, so Professor Smith may run the architectural design course at this point in time. However, Professor Jones used to run the course 2 years ago, and what that relationship between those two boxes means is that any particular course, although it must be run by one and only one person at any point in time, over a period of time the course may have been run by multiple people. So semantically, just by having a list of attributes in an entity using this modelling technique, Semantically, that means that each of the attributes will have a single value at any point in time, but that the history of the changes of those values over time is understood to be automatically recorded in some way. As a concept, the attributes can take multiple values over time, but only a single value at a point in time. And that's also true of the relationships. The arrow on the diagram means that although there is only a single relationship at any point in time, that over a period of time the relationship can have taken many values. So that's the way that time is dealt with using the modelling notation that I've chosen to use for examples in the rest of the course. So that's how to deal with time. Remove it from the equation entirely and choose a modelling notation that deals with time automatically. In summary, that removes significant clutter from the diagram, making it much easier from a communication perspective, and any technique can be adapted to represent time in this way. And that's really the topic of the next module. The next module deals with taking an existing data model and converting it using a number of techniques, one of which will be removing time.